Hello everyone, welcome back to the channel Code with AKJ. Today is day 40 of solving Geeks for Geeks problem of the day. Today's question is smallest window in a string containing all the characters of another string. So the question says here, given two strings S and P, find the smallest window in the string S consisting of all the characters including duplicates of the string P. So we'll return -1 in case there is no such window present. In case there are multiple such windows of same length, return the one with the least starting index. And here all characters are in lowercase alphabets. So coming to this example, time to practice would be our string, and we need to find TOC whether present in this string yes or not. So as we can see, there's a substring called toPrac where we can find TOC in it. So we'll return this particular substring with minimum length, which is our final output. Coming to this example, our string is this, and we need to find OZA in our string with minimum substring length. As you can see, there is a substring called APZO where we can find all these particular P characters in it with minimum length of substring. So in this case, our answer would be APZO, whose length would be 4. And they are expecting us to complete in O of n time complexity, and same with the space complexity. So today we'll be solving an interesting coding problem, finding the smallest window in a string S that contains all the characters of another string P. So we'll break this down into two solutions. First a brute force approach, then we'll move on to a optimal solution. So let's dive into it. So let's start by focusing on the brute force solution. Here what we can do is that we generate all the possible substrings of this string. We'll check substrings and compare it with the another string P. So for each substring, check if it contains all the character of string P, and we'll track the smallest valid substring. So here, by generating each and every substring of this particular string S, our time complexity would be O of n cube, O of n square for generating all the substrings, and O of n to compare each substring with our particular string P. Implementation goes like this. We'll start by generating substrings using two for loops, and for each substring we'll compare its character frequency with that of string P. So if it contains all characters of P, we check if it is the smallest valid window. The time complexity would be O of n cube, and space complexity would be O of n. So let's move on to the code and let's see whether it gets accepted or not. So this is a code for the brute force approach we have discussed, where we need to generate the substrings of this particular string S, and we'll compare each substring with these characters of P. So we have taken the size of the string S and stored it in variable n. I have taken the minimum length, which would be initially int max, and I have taken the string result, which would be -1 initially. So I have used two for loops to generate all the substrings. I have used the function substr to generate all the substring, and I have also taken the frequency map to compare each substring with the string P. I have iterated over the string P, and I have checked for the frequency of the characters which are present initially in string S. If in any case the frequency becomes negative, we can say that duplicates are present in string S, and we'll return false from there. So finally, after checking the characters of string P, we'll check if the contents all is true, and we'll also compare the length of that particular substring which is valid. So we'll track here the minimum length as well as it contains all the characters or not. So with these two conditions, we'll update our min length and our result. And finally, since we need to return the string which is valid, we'll return the result string, which stores the substring which is valid and has minimum length. So in this way, we'll tackle this problem using brute force approach, where we have used two for loops and a function O of n, which results as in O of n cube, and the space complexity of O of n, where we have used external data structure map. So let's compile and run this. As you can see, this problem approach gave us time limit exceeded, as our approach takes O of n cube time complexity. So we need to find a way or move on to an optimal solution which reduces our time complexity from O of n cube to O of n. So as we have observed that the brute force approach gives time limit exceeded, and The time complexity of this is more as our expected time complexity. So let's move on to the optimized approach where we'll use sliding window technique. Here the approach would be to use a sliding window to check the substring of S and dynamically adjust the window from left to find the smallest substring that contain all the characters of P string. So we'll maintain two frequency map, one for the characters of P and one for the current window in string S. And we'll expand the window by moving the right pointer to include the characters and contract by moving the pointer from the left side to exclude the unnecessary characters. So by using this sliding window approach, we can optimize our time complexity from O of n cube to O of n as we are iterating over the array just for once. And space complexity here would be O of n as we are using the external data structure map here, which is our expected time complexity and space complexity. So let's dry run with this example and let's move on to the code later. So I've maintained here a starting variable which starts and iterates over this string. I've taken the max length value which would be initially the size of the string, or we can put int max over here, and I've also taken the resultant string starting point which is initially 1. I have taken a map which will store the count of each and every character of the P string. Here our P string would be TOC, so the value would be 1, 1 and 1. So let's dry run this string S using our sliding window approach where we'll try to include the characters from the right side, and we'll check the current substring map, and we'll check whether this substring is valid by comparing it with our unordered map which stores the frequency of P string. And if it is valid, we'll try to shrink this particular window by removing the characters from the left side to get our minimum length. So let's dry run this. So we'll start from it I value 0. So the window will contain the character T. So we'll check this window has all the characters present in P string using a function check valid. So we'll maintain a function check valid which will give us answer in the form of true or false whether this particular current window has all the characters from the string P or not. So here current window has character T, so it gives answer as invalid as O and C are missing. So we'll move on to the next index and we'll add few characters from the right side in our window. So while moving our start point from I to 0 to I to 1, our window will contain the string Ti. So again we'll check using this function whether it is valid or not. Since again O and C are missing, we'll return invalid from here and we'll move on with the next iteration. So next iteration window will contain the string TIM which will also give us invalid function. Next window will get us TIME which will also give us invalid as a result. Same goes with T, O and P since O and C are missing here. So in this condition only C is missing here. When it comes to iteration 6, our window will have a string time top which also gives us invalid, and when it comes to time to PR it also gives invalid as an answer where we try to check this particular string with our map which whether it contains all the characters of P in this current window or not. Since the characters are missing, it will return invalid as an answer. So when we come to iteration 9, here our current window string would be time to pra. So from here we can say that it contains all the characters present in the string P, which is T, O and C. So here in this case the check valid function returns true, and when a function returns true, our main goal next would be to minimize the length of that particular substring since we need minimum length substring which is valid. So here what we'll do is that we'll try to minimize this window by excluding all the characters from the front. So here our length would be 10 and the resultant string which is our substring is 0. So let's minimize this window. We'll try to exclude all the characters from the starting of this window string, and here after removing character T, our string window would be IMETOPRAC. And since it is valid, we'll again try to minimize and exclude all the characters and try to get our length as minimum as possible. So let's remove I from here, and our current substring would be METOPRAC. Since still it gives a valid as a answer, we'll again try to remove the character from the start. We'll remove M. So our current substring would be ETOPRAC, and still we contain all the particular characters from the P, so it will return valid as an answer. And here length would be 7, and the result starting index would be 3. So again we'll try to remove the first character, and we'll get a substring value TOPRAC, and still it gives us the valid as an answer from the check valid function. And here our length would minimize from 7 to 6, and starting value would be 4. And when we try to remove one more character from this particular current substring, and it will give us invalid. So our minimized length would be 6, and starting point would be 4, and our string would be 2prac from this iteration of index 9. So since it gives invalid after removing from this current window substring, we'll try to move on with next iteration with I value 10, and we'll start from here OPRAC. We'll try to include characters from the end side, which is OPRAC. So till now, after 9 iterations, we found that TOPRAC is our minimum window string, which has all the characters from the string P. So after removing the first character from this current window string, we found that it gives invalid. So we'll try to maintain this as a minimum length, and we'll try to add the characters from the end side. So since OPRAC gives invalid, we'll try to add characters from the end side. So next iteration would add T into this current substring, which give us OPRACT, and we'll again check this using valid function. Since it gives valid, here our length is 6, which is same as the previous one. So let's try to again minimize this length by removing the characters from the starting point of this current window string. So after removing O, we can see that it gives invalid. So the O is missing in this substring, which is PRACT. So we'll try to stick with that, and we'll continue with the next iteration. So when we try to continue with the next iteration, we can observe that we won't find any more current substring which is a valid substring and which contains all the characters from the string P. So here we have two possible substrings, which is TOPRAC and OPRACT. So these are the two possible answers strings whose length is 6, which has all the characters present in our string P, which is TOC. So since we need to return the minimum length, we'll return the answer as 6 here. They would have asked the string, we can send or return any of the following string value. So in this case, our answer would be 6, and with the help of this approach, by iterating over this particular string by once, we can find our minimum length of substring which has all the characters of the string P. So here the time complexity would be O of n, and space complexity would be O of n, which is our expected time complexity and space complexity. So let's move on to the code and let's submit it. So this is a code for the optimal approach. We have discussed through dry running this particular example. And here I've taken the vector of size 26, which will store all the frequency of the string P. I've taken the starting value 0 and the size of the string S. I've taken the resultant length or max length in our case, which would be the size of the string initially, and starting point, which would be -1. I have taken one more current string vector, which will store the frequency of the current window string. I have iterated over the string S, and I have calculated the frequency of each and every character of the current window string, and I have sent this current value and the P string's frequency value in our function is valid, which will check whether each and every characters are being matched or not. And if it has, we'll calculate the length of it, and we'll compare it with our maximum length, and we'll update the maximum length, and we'll reinitialize the starting window value. So after doing this, we'll try to minimize the window by removing the starting character and by moving the index forward. So after doing all this and iterating over the string s, we'll check whether the maximum length is exceeding the size of the string or not. If it is exceeding it, it means it is invalid and we didn't found any window such. So we'll return -1, or else we'll return the valid substring value. So in this way, we have found and tackled this problem using our optimal approach, which is using sliding window technique. So let's compile and run this. So again, so let's submit. As you can see, this problem got accepted successfully and we have completed this problem in our expected time complexity and space complexity. So that's it for today. If you found this video helpful, please give a like, share and subscribe to this channel more coding content. I'll see you in the next video. Thank you.